Hello, my name is Josue Rosales. This is the second part on house prices. This slide is mostly about analysis of the houses. Um, so the first step I did was a histogram of sales prices of homes. This is a right skew histogram, and we have on the y-axis we have the number of houses. On the x we have the prices of the sales. The skew of this is a right skew histogram because it's just basically linked to the right and has 1.882. Basically, the closer to zero, the more of a normal distribution or equal distribution will be. On the next histogram, we have we decided to log it to have a more equal distribution. So I logged the prices of the cells. So we got a value of 0.121, which is basically close to zero, and it's more of a equal distribution, and this will help us on our modeling in the future. Because we want it to be normalized as much as possible. So on the next slide, we have the 7 top most correlated sell prices of houses. These are the top 7, and the highest one was the overall quality of the house with almost like 80%. Then we have like the total area, the neighborhood, external quality, pretty much things that people always look like. But now we can see that these things correlate with the sell price of a home, kitchen quality, garage cars, garage areas. So let me see. So on the other hand, we have the least correlated parts of features that are to a sell price, and some of these are not really that important. And the idea is to take them off of our modeling because they could be outliers. They could cause some problems into our modeling. And basically, some things are not even recognizable. Like you might need some people to actually evaluate these things. There's no better one known to the popular aspect of it, like MS subclass, and like you might need some experts to evaluate that type of feature. And so this comes into the subject of feature selection, and it comes to correlation. We want to choose the features that correlate the most on this. We might have to choose a threshold into selecting features, and basically it's try and test, and then until we get our highest accuracy on our modeling. Some other things that I looked into the columns there was like how people choose houses, or the things like, for instance, if a person were to choose two houses that are in the same neighborhood, one in great condition, one not, and the type of its values that it had. For instance, they had the overall condition were unique values from 1 to 10, which is already fine, but on the street, if it's paired or not was string, so compared to 0 and 1s, basically making these features more computable, especially if it's in high correlation to our modeling, if it shows importance. The method I've used was linear regression. It seemed like these to our data to work fine with linear regression based on the features we chose and how the trend went onto our graphs. Linear regression seems like a great fit. I put a meme here. The way we're going to test our accuracy was through the mean square error. We're going to use our train data, and then we're going to use k-fold, and then that's a pretty good indicator within our train data to show what is actually working or not. Good thing to show the accuracy. Finally, we want to be, once we do all this modeling and predict the prices, we want to compare it back to its real sale price, because before that we normalize it. We use log, so we want to compare it now. And then we actually get the real sale price after being used in our modeling. That helped. And that's pretty much it. I mean, this is the last step, just doing the opposite of log and getting our prices back. All right, I think that's it.